everyone. So today we have some question of organic chemistry asked in previous NEET exam. First question is, consider the following compounds and out of these we have to find hyperconjugation occurring compound. Okay, for hyperconjugation, wherever you have positive or free radical dot, you have to check the neighboring carbon to which this carbon is directly bonded. So these are the carbon to which this carbon is directly bonded. This is your alpha carbon, and hyperconjugation is shown only if this carbon is having hydrogen. Now this is with no hydrogen, this carbon is again with no hydrogen, so this will not show hyperconjugation. So it means your option number 1 is one cannot be the answer, so we can eliminate the option number 3 and 4. Remaining option second. In second compound, this is again pH means phenyl ring. Now in phenyl ring, phenyl carbon to which this carbon free radical is bonded, this is not having any alpha hydrogen. So it means carbon number 2, this compound number 2 will also not show any hyperconjugating structure. So second option is eliminated. First option, sorry. Then in third case, this is your free radical, and these are the carbon to which this free radical is directly bonded. Now this carbon is also having one hydrogen, this carbon is also having one hydrogen, these are alpha hydrogens, so it will show hyperconjugation. So your answer 2 is correct. Next question is, enthalpy of hydrogenation we have to find. What should be the order? Enthalpy of hydrogenation is a measure of stability of compound. If enthalpy of hydrogenation is high, it means that unsaturated compound is unstable. If enthalpy of hydrogenation is low, it means that compound is highly stable. Now out of these three compounds, compound number 1 is having a ring hexagon which is having 4n plus 2 pi electron. This ring is aromatic. This ring is anti-aromatic, and this third ring is simple cyclohexane ring. So we know the stability. Aromatic compounds are highly stable. It means they should have very low enthalpy of hydrogenation. Enthalpy of hydrogenation should be least in case of 1. 1 should be at the end. So this is in compound number 1 and 2. So we can eliminate option number 3 and 4. Now out of 2 and 3, because this is anti-aromatic, so this is highly unstable. This compound is highly unstable. Why it is highly unstable? Because here the carbon is sp2 hybridized carbon. This carbon is sp2 hybridized. So here concept of bond angle comes. So because this bond angle is this is 126 180 by m6. So this is, so we can find the angle. So this angle is less due to the cyclic structure. As a result, it has strain, and that's why it is less stable. If it is less stable, it means it has high enthalpy of hydrogenation. It will have highest value. 2 should be at the very beginning, so option number 2 is correct. Which statement is not correct? Not correct. So it is your nucleophile. About nucleophile. Nucleophile, nucleus loving, electron rich species these are. So these attack on low electron density side. This is correct option. Nucleophile are not electron seeking. Yes, this is also correct option, because these themselves are electron rich. Ammonia is nucleophile. This is also correct. Nucleophile is a Lewis acid. No, these are Lewis bases. The correct option is, which is not correct, is third. Answer is option number 3. Now next is the value of Kb, means we have to find basic strength, and the relationship between these two is Kb is directly proportional to basic strength. Higher Kb means stronger base. So out of these 4 compounds, we have NH2 here, amine. Now amine, nitrogen is having lone pair. So higher the electron density, stronger will be the base. Okay. Now in compound number 2, as this lone pair is in conjugation with the ring, so this cannot be the answer. This cannot be the strongest base, but we have to give the order. Okay, we have to give the order. Okay, so this is in conjugation, so this will be very, very weak, means its Kb will be low. Okay, so we can compare between these two, 1 and 2. 1 will be stronger base than 2. Okay, out of 1 and 3, because this NH2 is attached to that carbon which is bonded to phenyl ring, and this will act as electron withdrawing group here. So as a result, it will decrease the electron density on nitrogen. So your compound number 1 will be less basic than compound number 3. Okay, so we can arrange them. It is 3 is stronger base than 1 and 1 is stronger base than 2. So our overall order is 3 is stronger base than 1 is stronger base than 2. Then last fourth compound, it is again very weak because its lone pair is in conjugation with the carbonyl compound. They are not available. There is decrease in electron density. So it will be weak acid. It will be the weakest acid. This compound number 4 will be even weaker than compound number 2. So we can arrange further. 2 is less than 4. So decreasing order, fourth compound should be at the end because 1 cannot be the answer. 1 cannot be at the end. So this and this eliminated. So we left with 2 options. This is 3 at the very beginning. So 3, 1, 2, 4. In pyrrole, this is the structure of pyrrole. You have been asked the highest electron density region where we have highest electron density maximum. So for that you cannot draw the resonating structure. With the help of resonating structure you will be getting electron density highest at position number 3 and then position number 5. So 3 and 5 cannot be the answer because these positions are not equivalent. Either if you are saying 2 is having high electron density, then parallel to it will be 5, 2, 5 and 3, 4. These are equivalent position. Why these are equivalent? Because there is plane of symmetry. So if we cut this molecule in 2 equal halves along this plane, so this 5 is reflecting 2 and 3 is being reflected by 4. So these are equivalent positions. So 2, 5 and 3, 4. Okay. So 2, 4 cannot be the answer and 2, 3 cannot be the answer. So we left with 2 and 5. So how this 2 and 5 is the correct answer. How this 2 and 5 is having highest electron density, how we find? Actually we make attack nucleophile over this ring and then electrophile on this ring, and then we compare the stability. If this electrophile is attacking on carbon number 2, it means this electron pair is shifted to carbon number 2 and this 3 is getting positive charge. If it is acquiring positive charge, that means now we'll compare its stability. Okay, so it is resonance stabilized. It can undergo resonance. In this way we will get more number of resonating structure. But if this molecule is being attacked at position number 2, a number of resonating structures will be very, very less. We will be getting such type of arrangement where carbon this attacked at position number 3 by electrophile. So it means positive charge on this carbon. Moreover, this is attached to nitrogen, which is electron withdrawing through inductive effect, but it is electron releasing through resonance effect. So less number of resonating structure, it is less stable. So that's why attack at 3 is less favorable. It is attack at position number 2. Similar way we can make it attack on position number 5. So preferable attack is at position number 2, then at position number 5, then position number 3. This is the order of reactivity. So its correct option is